Hi, welcome to Math Code. If you're new to this channel, kindly subscribe. Encourage your friends to subscribe also. So today we are going to talk about the force, the momentum, and the acceleration. So let's go. Okay, so our discussion today will be basically about the force, the momentum, and the acceleration. So we want to know what the force is. But before we know force, we have to be knowing what the acceleration, what the momentum is. So we are saying we have to first know momentum. And what is the definition of momentum? So momentum of a particle is the product of its mass and its velocity. We are saying if we have a particle of mass, maybe small m, and this particle has a velocity, maybe small v, then the momentum of this particle, which we can call capital P, is the same as the product of mass and the velocity. So this P is the same as m times v, and we can say that P is the same as mv. So this is basically the equation that relates the momentum, the mass, and the velocity. What are the SI units of this momentum? So we know that the SI units for mass are the same as a kilogram. The SI units for velocity are the same as a meter per second. Sometimes they can write it as meter per second, and therefore the SI units for momentum will be the same as a kilogram, then times a meter per second. I hope you get that. So we can see this through an example maybe. So example 1, so we have a particle of mass so we have a particle of mass 5 kilograms, and this particle is moving with a velocity of 20 meters per second in the northeasterly direction. So this particle is not moving horizontally, but rather it is moving in the northeasterly direction. So we want to calculate the momentum of this particle. So the momentum of this particle is, we know that it will be in the same direction as its velocity. And what will be the magnitude of this momentum? So the magnitude of this momentum, we've called it P. So we have that the magnitude of momentum P is the same as the mass times the velocity. So our P will be the same as the mass, which mass is 5 kilograms, then times the velocity, which is 20 meters per second, and this momentum will be the same as 100 kilograms meter per second. So this is basically the magnitude of this momentum, but remember this particle is moving in the northeasterly direction, so we have to get the momentum in that direction. So if our particle is moving in the northeasterly direction, basically it means it is moving like this. So this is the northern direction. This is the eastern direction. So it means our particle basically it is moving in such a direction. Okay, so we know the horizontal direction is I, the vertical direction is J. So if in this case we assume that this particle moved a unit in the eastern direction and a unit in the northern direction, so we are saying that it is moving one unit and one unit in the northern direction. So what would be this angle here? We would get that angle there and that angle there. Basically, it would be the same as, because this is 1. So if I say maybe tan theta is the same as the opposite over the adjacent, I'll get 1. So which means my theta will be the same as tan arc of 1, which means my theta would be 45 degrees. Okay, so if we know the angle, then we can basically get the momentum in each of the directions, in the eastern direction and in the northern direction. Okay, so in the eastern direction, we know what the magnitude of the velocity northeasternly is. The magnitude of the velocity in the northeastern direction, which is this direction, is 20. So what is the magnitude of the velocity in the eastern direction or the horizontal direction? That would be the same as 20 cos of theta. This is the velocity horizontally. I hope you can see that from the diagram. And this will be the same as 20 times cos of 45. So this is the same as 20 times, we know cos of 45 is 1 over root 2. So I can say this is 20 over root 2. And in the horizontal direction, which direction is I? Similarly, I can get the velocity vertically, and the velocity vertically would be also the same as 20 sine of theta, which is the same as 20 sine of 45, which is the same as 20 over root 2, and this is now in the vertical direction. Okay, so now we want to get the momentum in the northeasterly direction, and that momentum would basically be the same as P is the same as mv. So my P is the same as M. We know my M is the same as 5. Now what is the V? The V is the sum of the velocity horizontally and the velocity vertically. So which means my V is the same as 20 over root 2 horizontally, then plus 20 over root 2 vertically. Okay, so when I calculate this, I can pull out the 20 over root 2, it is common. So I can pull out 20, there is a times 5 there over root 2, it is common. Then I plus j, this is 100 over root 2. So this is the same as 100 over root 2. When I do what we call rationalizing, this will be the same as root 2 over root 2 into I plus j. Okay. So what is this answer? This answer is the same as 100 root 2, then the whole of it over 2 into I plus j. So I can cancel this to 50, and I'll end up with 50 root 2 into I plus j. And basically this will be the momentum. So these are kilograms meter per second. So this will be the momentum of this particle in the northeasterly direction. Okay, so after knowing what the momentum is, then we have now very good knowledge to help us discuss what the force is. So we can now comfortably discuss the force since we know the momentum. And the force, the principal force was basically laid by Newton from his equations of motion, and these equations of motion can be modified in the modern era. So the first one is every body continues in its state of rest or with uniform momentum unless acted upon by an external force. So a body will continue resting or it will move with a uniform momentum unless it is acted upon by an external force. Then the second one is the rate of change of momentum of the body is directly proportional to the applied force. And this second one is the most important one. So we are saying that the rate of change of momentum of the body is directly proportional to the force applied. So we know that our momentum is P. So we are saying that the rate of change of momentum of this body, so the rate of change of momentum P. So when I hear the word rate, it means time. So we are basically saying that the ddt of P is directly proportional to the force applied. So I'll have dP dt is equal to some constant, then times F. Now, if we assume this constant is the same as 1, then basically we'll be having dP dt is equal to F. So what are we saying? We are saying that the force of the body is basically equal to the rate of change of momentum of this body. But what is P? We know that P is the same as mass times velocity, so which means my force will be the same as d dt times mv. We know mass is a constant, so I can pull it out and I'll have m d dt of v. So basically this is how we can derive the force from the momentum of the body. And we know this m is kilograms, then dv dt is the same as a meter per second, then divide by a second. So this is a meter per second squared, and that is why the SI unit for force is the same as a kilogram, then times a meter per second, and or we can call it a Newton, capital N. Okay. So after knowing that, how do we get to know the force related to the acceleration? So we now know that the force is the same as dp dt, and we have ended up with m dv dt. So, but we know what dv dt is. dv dt is the same as the rate of change of velocity, which is actually the acceleration. So therefore, the F is the same as ma. And In mathematics, this is what we call the equation of motion. So most of the calculations we are going to deal with we are going to be helped by this equation, which is our equation of motion. Okay, so maybe we can do an example. So this is our example like this. So the rate of change of momentum of a body is directly proportional to the applied force. Sorry, this is the definition of the force. So this is our example. So we have a particle of mass 2 tons is moving in a straight line with an acceleration of 12 meter per second squared. So this is a meter per second squared. So we want to find the resultant force acting on this body. So we now know that our force is the same as m then times the acceleration. That's what we've just proven here. So remember that all our units should be the standard units or the SI units. So our force is the same as the mass. The mass is the same as 2 tons, but we know that 1 ton is the same as 1,000 kilograms. So this will be 2 tons, then times 1,000 kilograms, that is the mass, then times the acceleration of this body, which is 12. So my F is the same as 2,000, then times 12, and this will be the same as 24,000, and this will be newtons. As simple as that. Example 3. So this is our example. So we have a constant force of 60 newtons is applied to a particle of mass 5 kilograms. Find the acceleration it produces if the particle starts from rest, and then we find the speed of the speed required in 10 minutes. So we can first find the acceleration. So we have the force. So from this question, our force is 60 newtons. It is applied to a mass of 5 kilograms. And in the first question, they want us to find the acceleration. So from the equation of motion, which is force is equal to ma, our force, which is actually 60 newtons, will be the same as 5, which is the mass, then times a. So 60 is the same as 5a over 5 over 5. So which means our a will be basically be 12, and these are meters per second squared, which is our acceleration. Now, if this particle starts from rest, they want us to find the velocity it acquires, and this velocity, so the question is here. So if the particle starts from rest, find the speed acquired in 10 seconds. So now it is using an acceleration of 12. So we want to find the speed acquired, and that is what we always call the final velocity. So from the equation of motion, v is equal to u plus at. We know this. So we know that the u is the initial velocity. So since this body is starting from rest, the initial velocity u will be 0. The v is the final velocity we are interested in. The time is given as 10 seconds. Note that it is given in seconds, and therefore if it is not given in seconds, you have to change the units given to seconds. So we want to get v, which is the same as u plus at. So our v is the same as 0, then plus a. We have calculated our a as 12, and the t is the same as 10. So which means our v will be actually 120, and this is a meter per second. Very good. Okay, so we can do maybe one more example. I hope you're having now a good insight of what the force is, what the momentum is, and what the acceleration is, and you can derive each of those from the other. You can derive the equation of motion. So before we go to the final example, if you're new to this channel, kindly subscribe to my channel. Let's learn together. This channel will be having a lot of content right away from lower secondary to university. So you can always go to the comment section, comment which topic you would like to learn, and we shall always make the video for you so that you learn. If you want live sessions, live interactions, I will provide the email where you can always reach me so that we can have live sessions if you're really interested. Okay, so we go to our last example for today. Okay, so what is going to be our last example tonight is this. Okay, so this is our example. I hope you follow. So we have a particle of mass 2 kilograms. This particle is moving under the action of two forces. And these forces are of magnitude 6 newtons and 4 newtons, acting at 60 degrees to each other. Find the acceleration of this particle. So we are interested in the acceleration of this particle, and we can first draw out a sketch that will help us. So we have a particle, it has, so if this is my particle, it has a mass of 2 kilograms. So it is moving under the action of two forces. So two forces are acting on this particle, and these forces are acting at 60 degrees. So I can draw this like this. So this is my particle of 2 kilograms. These are the two forces. This is 60 degrees. So I can call this 6 Newton, and I call this 4 Newton. Or if I want, really it really doesn't matter. I can call this 4 Newton. and I call this 6 Newton, whatever. So we want to calculate the acceleration of this particle. So whenever we land on problems like this, where two forces are acting at a certain angle, then usually we have to first draw out a parallelogram. So this is my my figure. It is like this. So what I do, I can just prolong these sides to form a parallelogram, and I know that the interior sum angle of a parallelogram is 360 degrees, and also the opposite angles of the parallelogram are always equal. And therefore, if this is 60, then this one would also be 60. Now, since the sum is 360, then I just get 360 minus the sum of these two, which is the sum is 120. So when I subtract 120 from 360, I get 240. 240 divided by 2, because I know these two angles are equal since they are opposite. So each of them will actually be, so this angle here will be the same as 120 degrees, the same as this angle here. It is also 120 degrees. So this one is our 4 Newton. Sorry. This is our 6 Newton. And this is our 4 Newton. So we can first get the resultant of these two forces, and I can call it capital R, for example. So what will be the resultant? Using the cosine rule, which I want to believe that you know how to prove. So the cosine rule, which is this R squared, is equal to 6 squared plus 4 squared minus 2 times 6 times 4, then times the cos of the angle which is opposite to our magnitude R, and that angle is 120. So my R squared is the same as 36 plus 16 minus this is 24 times 2, 48 maybe, then cos of 120. So my R is actually the square root of 52 minus 48 cos of 120, and my R, you can put that on a calculator, and we shall end up getting R as, what is cos 120? Cos 120, 0.5, 0.5 times 48. So we are dividing by 2, we just get 24. Remember, this is the same as 52, then plus, because cos 120 is negative 0.5, so it will change to a plus of 48 divided by 2, which is 24, and this one will be the square root of 76, which is Newton. So this is the resultant force of these two forces, 6 and 4, acting at 60 degrees. Okay. So after getting that resultant, remember we want to get the acceleration of this body. So the acceleration, we know how to get the acceleration from the equation of motion. The force is equal to ma. Okay? But now the force in this question is what we've just calculated, which is the resultant force. So we shall have root of 76 is equal to m, which is a 2, then times a, So the square root of 76 is equals to a over 2 over 2. So we can end up with our acceleration as 76 root of 76 over 2, and you can put this on a calculator and probably you'll get 4.359 meters, depending on the number of decimal places you want to consider. So you get something like this, 4.359 meters per second squared. And basically that is our acceleration. But remember, we have to get the acceleration and the direction, okay? So we want to know what the direction of this acceleration is. So from this figure here, I can pull out one part of that figure, for example. So I have this figure like this. I hope you can see that, where this one is 120 degrees. And this is the area we have just calculated as root of 76. These are newtons. Now, the direction, we are interested in this small angle. We don't know that angle. Whereas we know that the whole of this angle here is the same as, so the whole of this angle here is the same as 60, but we don't know which angle is this, neither do we know this one. So we want to calculate this angle to the horizontal, this angle that is made between our resultant root of 76 and the 6 Newton force. Okay, so remember, we know that this is our 4 newtons, and therefore if I use my sine rule, which I also want to believe that you know how to prove, maybe I can be somehow organized. Therefore, I'll use this place. So this is what we are interested in. This is our figure. We are interested in this angle, which we can call alpha. This is 6 newtons. This is 4 newtons. And this is the same as the root of 76 newtons. So we are interested in alpha. And using sine rule, we know what sine rule says. So the sine rule is the same as the force over the sine of the angle opposite to that force is equal to the other force by the sine of the angle opposite to it, okay? So we know that this angle is 120 degrees. So I can use this force root of 76 and this force 4. So I'll have the root of 76 over the sine of the angle opposite root of 76, which is 120. And this is the same as the 4 newtons over the sine of angle that is opposite 4, which is alpha. So when I do the cross multiplication, I'll have root of 76 sine of alpha is equal to 4 sine of 120. So I can have sine alpha is equal to 4 sine of 120, then divide by root of 76. How do I get alpha? If I want this alpha, I take the arcs, the sine arc. So this will be sine arc of 4 sine of 120 over root of 70 over root of 76. Okay, and when you calculate this in a calculator, you will end up with 23 degrees. Okay, so we can conclude that therefore the acceleration of the particle is of magnitude. So most students fail to conclude, but this is very important. To core is conclude, and most students usually forget to calculate this direction, but surely it is very, very important. So I can therefore conclude that the acceleration of the particle is of magnitude 4.359 meters per second squared in the direction 23 degrees to the horizontal. We are saying to the horizontal because we calculated the angle that is between our magnitude and the 6 force Newton. I hope you can see that. Someone would have chosen to calculate this other angle, of course. So someone can choose to calculate this angle, which is also okay. But basically, I chose to calculate this angle between the magnitude, which is the root of 76, and the horizontal. And our conclusion would be something like this, and our example is done. Now, this should be enough for today. If you have any comments or any clarifications needed, kindly you can go to the comment section, comment, and I'll look at the comments and I'll get back to you. Now, if you're interested in some topic, then you can still write in the comment section and I'll look at the comments. I'll make a video about that topic you're interested in, and you'll be able to look at the video. If you need the live sessions, if you want to interact with me one-on-one, this is my email. 1 minute of share. So I hope you can see. So this is my email that you will use. 1 minute, please. Okay, so if you're interested in the live sessions, you want to talk to me personally, you can send me an email on s@gmail.com. At gmail.com, or you can send an email on at gterm.in. All these are small letters, please. So if you send your email on one of these, I'll be able to receive it and I'll be able to get back to you in a very, very short while. I hope you've copied the emails. So once again, thank you so much for joining the Math Code. Thank you for being with us. Kindly, if you're new, subscribe to the channel. If you feel this video has been very important for you, you can click the like button. It will be very, very important to me. Thank you and see you next time.